Hello everyone, I'm going to introduce you to a Java project made by myself, Senia Kalma, and by Magnezi. Our project is basically a maze game which features generating a new maze, getting hints, solving, and setting specific settings for our game. And of course, you can play. The most interesting algorithm we used in our project is the A-star algorithm, and here's its pseudocode. We used it as part of the strategy pattern to solve a maze. The A-star algorithm finds the quickest path from a received star state to a received goal state. It does that not only by calculating the cost from the star state to the current state, by breadth-first search represented as the g-score in the pseudocode, but in addition it calculates an heuristic cost and adds it to the total cost. The heuristic cost is basically an estimated cost to get from the current state to the goal state. By using the total cost, we find the best solution in a very fast way. Our project architecture is where a remote control GUI starts the server using our MVP pattern, and another client GUI remote starts the online model client, our player. Then the client sends a problem, basically a command, to the server, where the server calculates the solution and sends it back to the client. This connection is made using separate TCP connections over the internet. After that, the server stores the calculated solution to a database using Hibernate or to a file using the Huffman coding algorithm. First of all, we'll demonstrate how our server works. We'll start it, and as you can see, it shows us our IP address and port number. We can load different game settings. It allows us, for example, to change the method of generating or solving a maze. We can load different server settings too. By that, we can change settings as the port number, number of allowed clients, or even change the saving method, Hibernate or Huffman coding. For example, here's a Huffman coded file containing gibberish for us, but valuable data as already generated mazes and their solution for the game. And here's a Hibernate saving, setting the data in the table, mazes as string, their name, and a solution, if there has one. Now, we can see that the server is independent from the GUI by closing the GUI and seeing that the server is running undisturbed. We can start the GUI again. And now open some clients, and one of them will generate a new maze. Because of that, all the connection is made over the internet. We can make sure that both of the clients can open the same maze at the same time. Now, we'll show the game features. We can change the size of the window, and the maze size will change correspondingly. We can change the background, or even the character color. We can set it a picture, one of the defaults, or an external one. And we can set an animation. This time we'll choose an external animation. And now you can start playing. You can move using the arrow keys and the mouse. You can get hints from the server. You can move diagonally. And of course you can win. And if you're feeling lazy, you can start from the start and get a solution. You just need to ask, and then to show it. And there it's pretty easy. Now we'll close the server completely, both the GUI and the server itself. Now, when we'll ask for a clue, we'll get a message that it can't connect. And this is our running application. In our project, we mainly used the MVP design pattern. It allowed us great flexibility to switch between the independent model and view, while the presenter observes and commands them. At first, the view sends a notification to the presenter of a new event. Then, the presenter sends one or more commands to the model. After processing the commands, the model notifies the presenter that it has finished. The presenter sends the processed commands to the view to display the final result to the user. Now let's talk about the client code. As we mentioned before, our code is implementing the MVP design pattern. We have the model, which split it to the offline model and the online one, the presenter, and the view, which split it to the CLI and the GUI. And as you can see from the run function, we can see the easy utilization of the MVP, its flexibility, and the easy change of the parts. As you can see from the difference between the CLI, command line interface, to the GUI, graphic user interface. We have the presenter and the model stays the same. We only change the view from the CLI view to the game window, which is basically a GUI. And by the differences between the GUI and the online GUI, where the presenter and the view stays the same, we change only the model from the offline model to the online model. Now let's move to the server code. It's based as the client on the MVP design pattern. We can see the presenter, the view, and the model. Now we start by initializing the server with the port and the delay that were set in the properties file. After that, we set the executor with the maximum number of allowed clients, as was set in the properties file too. Then we can see the server waits for some client to connect. After that, it sends the client to be handled at a generic client handler in a thread to support multiple users. The client handler which the server receives from outside using the strategy design pattern, allows us a fully generic server with no dependencies. Even the GUI is generic. After that, the client handler finishes handling the client, and we close the connection with the client. After seeing how it works in theory, let's see how we implemented the A-star algorithm in our code. First of all, the A-star algorithm received in its constructor the heuristic function, with which it calculates the estimation of the cost to the goal. We can see that our main function receives a searchable, an interface, which is an object adapter that defines a generic function of a search problem. After implementing that interface, we can use the A-star algorithm on every search problem, implementing the searchable interface. In addition, we can notice that the A-star algorithm returns a solution, again, an interface that describes a generic solution. And that's it. Thanks for watching.